Alright, what's up guys? In this video we're going to pick up with some multivariable calculus, and we're going to be talking about the two-dimensional gradient here. So we're asked to calculate the two-dimensional gradient of the given function, or for the given function. So we're given this function of several variables, f of x comma y is equal to cosine of 4x squared minus 4y. We want to calculate the gradient. So let me just remind you of the formula for the two-dimensional gradient. So remember, that's just del of x comma y is equal to f sub x, x comma y, comma f sub y, x comma y. And remember, that's just equal to the partial of f with respect to xi plus the partial of f with respect to yj. That's how we calculate our two-dimensional gradient. So we just need to compute our partial derivatives, or find our partial derivatives, and we'll take it from there. Notice that in this case, we're not asked to calculate the gradient at a point. You may be given a question like that from time to time, where they say calculate the gradient, whether it be in 2 dimensions, 3 dimensions, and they may say at this particular point. In this example, we have no point, so we're just calculating the gradient. I guess I'll do a video where we do one with a point, maybe in another one. So let's just find the partial derivatives here and kind of get that out of the way, obviously. So we need to take the partial of f with respect to x for our function, cosine of 4x squared minus 4y. So make sure you're good with taking partial derivatives. So remember, when you're taking a partial derivative, let's just say in our particular case with respect to x here, we treat the other variable as a constant. So to differentiate cosine of 4x minus 4, minus 4y, we will use the chain rule, but treat y as a constant. So what that means is we'll get negative sine of 4x squared minus 4y multiplied by 8x, and therefore we can say that the partial of f with respect to x is just going to be negative 8x sine of 4x squared minus 4y. So that's the partial of f with respect to x, because remember what the chain rule says. The chain rule says I take the derivative of the outside function, leave the inside alone, and multiply by the derivative of the inside. So that's the formula for the chain rule from first semester calculus. Just kind of loop that in with the idea of partial derivatives, which is what we're talking about. Okay, so that's the partial of f with respect to x. The next thing we need is the partial of f with respect to y, so that we can get our gradient. And again, it's the same function, cosine of 4x squared minus 4y. Same thing here, we're taking the partial derivative in this case, so we're treating x as a constant now since we're partial differentiating with respect to y. So in this case, when we take the partial derivative, we'll get 4 sine of 4x squared minus 4y. So that's our partial derivative there. So for our final answer, all we have to do is write it out, and then it'll give us our two-dimensional gradient. So our 2D gradient in this case is going to simply be, it's going to simply be del of f of x comma y. And it's just going to be equal to negative 8x sine of 4x squared minus 4y. And then we'll just add that to 4 sine of 4x minus 4y. And we need to tackle our unit vectors in, So this will be our answer. That'll be our gradient for this function. All right. So hopefully that made sense. Relatively straightforward process if you know how to take partial derivatives. All right. So if you got any questions about it, let me know. But other than that, I will see y'all next time.